Good morning, on and all present. Here I am Nandini, working as an assistant professor in SNS College of Technology at the Department of Computer Science and Technology. Today we are going to see a topic on what is autoencoder with its basics and application using data design thinking framework. As we have seen that autoencode is an unsupervised neural network used to learn an effective representation of data. It aims to reconstruct its input while learning important features. There are main components like encoder, latent space, and decoder. Loss functions used here are mean square error, mean absolute error, and binary cross entropy. Types of autoencoders like basic autoencoder, denoising autoencoder, sparse autoencoder, and variation autoencoder. Yeah, problem statement we define here is to automatically learn the compact representation for high dimensional data enables effective reconstruction and generations, which is used to reconstruct the effective generation with the help of these autoencoders. Next is with the help of this we are going to see what is an empathy phase. The real world of data, it is a high dimensional noisy difficulty analysis which is used to manually future extractions as time consumption and inefficiency used to capture the hidden patterns and complex data. So it can be seen as larger and complex data sets, noisy images or signals, difficulty in identifying the hidden patterns. For example, doctors need clear medical image from noisy scanners. Been used here. Next one is how we are defining this problem or how we are identifying it. Need to learn latent representation that enable efficient data reconstruction for complex high dimensional images. It clearly defines the problem that how it is used to reduce the data dimensionally without losing an important information. It removes how it removes a noisy effectively. What to detect anomalies in normal data has been identified here. Next is an ideate, generating a solution. Here, how we are generating a solution means by learning a meaningful futures. Encoder learns compressive futures. Decoder reconstructs the original data. Different variation handle different data issues. Idea generated, image denoising, data compression, future extraction for classification of data. This ideation involves generative architecture, create the human AI interaction, scalable content creation. Next one, prototype. So design an encoder to compress the input in a latent representation, which connects a decoder to reconstruct the generated data from the latent space, used to train a network by minimizing reconstruction loss using the input data, test the model on new data and redefine the latent representation. That means in this prototype, input to encoder, encoder to latent space to decoder, decoder to output is being trained using a reconstructional loss. This prototype includes image compression, noise removal models, anomaly detection systems. So this prototype is a good solution to build a proper autoencoding space. Next one, there are some types of autoencoders. Basic autoencoder, denoising autoencoder, sparse autoencoder, and variational autoencoders. Applications used here. At last, how we are going to test this and evaluate these improvement phases. Here, a functional testing, user feedback validation, performance and reliability testing have been used here. So model outputs are tested and redefined. Compare the original and reconstruction data, measure the reconstruction error, improve the accuracy by turning the parameters. The applications tested here are fraud detection, industrial fault detection, medical image enhancement are being used here. So these autoencoders, we conclude by saying that when application through the design thinking framework, it provides a human-centric solution data representation effectively, improves the quality and insight extraction. These autoencoders are powerful tool in modern AI applications. Thank you so much for the video.